Welcome to qnawire.
You're asked to calculate the theoretical isoelectric point, that is Pi, of different dipeptides using the pKa values from a table. So, in general, what we're going to do is whenever an amino acid has only two pKa's, meaning we are going to have only pKa1 and pKa2, meaning that the residue is neutral, then the calculation of the isoelectric point is equal to pKa1 plus pKa2 over 2, just taking the average direct. The other scenario that we may have is when the residue is acidic. That means that the pKa of the residue, or pK residue, however you have it, in this case from the table, the pK for the residue is lower than 7. In this case, what you're going to do is take the average of the two lowest pKa's. And finally, if the residue is basic, which means that the pK for the residue is larger than 7, then you're going to take the average of the two highest pKa's. So with this into account, what we're going to do is an example for each of them. I'm going to start with a neutral case, which is alanine. From your table, the pKa's that we have is the pKa from the carboxylic acid part of the amino acid is equal to 2.34. We know that the pKa for the amino part of the amino acid is equal to 9.69. Thus, the isoelectric point is equal to 2.34 plus 9.69 divided by 2, which gives 6.015. Now, let's go for the case where the residue is acidic. And I'm going to take the example of glutamic acid, which has the following pKa's. In the carboxylic acid part, we have a pK of 2.19, pK1. Next, we're going to have on the amino part a pK equal to 9.67. This is pK2 or pK2. And finally, on the residue, the pK for the residue is equal to 4.25. So the calculation of the isoelectric point, since we have an acidic residue, as you can see here from the pK of the residue, is going to be equal to 2.19 plus 4.25 divided by 2, which gives 3.22. Finally, for an example for when the residue is basic, we're going to take the case of lysine, which has the following pKa's. We have 2.18, this is pK1, pK2 is equal to 8.95, and pK for the residue is equal to 10.53. In this case, as you can see, the pK of the residue is larger than 7. That means we have a basic residue without even having to look at the structure. And the isoelectric point would be equal to 8.95 plus 10.53 divided by 2, taking the average of the two highest pKa's, which gives 9.74. So those are all of the possible cases that you're going to have in the whole table, and hopefully this is going to allow you to finish up the rest of the results. Thank you very much and have a good one.